Assalamu alaikum, guys. Now I will be speaking about factorization by difference of two squares. Okay, so we say the difference of two squares problem can be factored as follows. A squared minus b squared will be equal to a plus b times a minus b, or a minus b times a plus b. It doesn't matter which one comes first. So all you need to do to factor these type of problems is to determine what numbers squares will produce the desired results. Right, so the last step will be to do this, to determine if the remaining factors can be factored any further. Right, so, this is the main rule here. The difference of two squares, you see in maths, the difference is the subtraction, or the minus sign. When we say difference, it's a minus sign, right? The sum is plus sum. So when I say difference of two squares, if you look at this number, a squared, b squared. So 1 squared and 2 squared. I have two squares here, which are a squared and b squared. So there is a minus sign in between. So a squared minus b squared. So that's why I call it the difference of two squares. Right, so when I see this a squared minus b squared, I need to know that it is a plus b times a minus b. So these are the factors of a squared minus b squared. So this is always in this form. A squared minus b squared is a plus b times a minus b. Okay, so now a squared minus b squared equals to a plus b times a minus b. Right, this is our general rule. Now let's do a few examples with this. 16x squared minus 25. You see, since I'm busy with the difference of two squares, right? Then if anything is not in that form, in the form of an exponent, first thing I need to do to write it as an exponent. So as you can see here, 16x squared. If I write this, you see here, x squared is in the form of an exponent, but 16 is not. 16 is what? Just gonna write it here. Right, we do know that the 16 is basically, if we write it square of which number? Square of number 4. So 4 to the power of 2 is 16, right? Then I have 25. 25 is square of which number? It is square of number 5, because 5 times 5 is 25. 4 times 4 is 16. Right, so 16x squared is, when you write it as in the form of an exponent, it becomes 4x in the bracket to the power of 2. And remember this rule, we said the power of bracket is power of all the terms inside the bracket. What I have inside the bracket? 4x. 4 times 2 is 16. X times 2 is x squared. Right, that's why I can write this 16x squared like this, 4x to the power of 2. Then I have minus 25. Because now when I look at this, it doesn't look like a difference of two squares, because I don't see any square. That's why I need to write this in the form of an exponent. So I need to figure out now, 25 is the square of which number? So 25, we do know that from the perfect squares, it is 5 to the power of 2. Then I'm going to write that. If I write everything like this, so you can see now it's 5 to the power of 2. So this is same as this, but when I look at it, it doesn't look like the difference of two squares. It doesn't look like this. Yeah, that's why I need to write it like this in the form of an exponent, so it will look like this. Then I can work out 4x to the power of 2 minus 5 to the power of 2. So this is basically this, 4x to the power of 2 minus 5 to the power of 2. Now it is a difference of two squares, because one square is 4x to the power of 2, the other square is 5 to the power of 2. And in between I have minus sign. So this is the difference of this square and this square. Then when I look at this, we said a squared minus b squared is this, a plus b times a minus b. Then I'm going to say 4x, this is 1 squared, that square is, right, 5. 4x plus 5 times 4x minus 5, a plus b times a minus b. 4x plus 5 times 4x minus 5. So then my answer is going to be 4x plus 5 times 4x minus 5. Okay, the next question, yeah, 3x squared minus 75y squared, right? So in this question here, what is common here? 3. You see, this can be divided by 3 and this can be divided by 3. So I'm going to take both of them in the bracket of 3. So if I do that, 3 inside the bracket, I will have x squared minus 25y squared. Okay, this example is a bit difficult, right? So we need to be careful when we're doing this question. 3, again, guys, so when we take something in the bracket of a common factor, the common factor is 3. Yeah, 3 is common factor of 3x squared and 75y squared. Why? Because if I do an inverse operation here, when I time this, 3 times x squared will be 3x squared, 3 times 25y squared will be 75y squared, right? So that's why this is the simplified form of this, right? I took it in the bracket of 3. Okay, I will continue now. Okay, now, because I took it in the bracket of 3, x squared minus, now 25 is, we said, 5 squared, right? Then 25y squared, if I write 25 also in the form of an exponent, is going to be 5. Y, right? Y squared, I'm gonna write y here because I'm gonna take these two inside the bracket, then put the power on the top. So this power will be power of 5, power of y. Power of 5, 5 times 5, 25. Power of y, y to the power of 2 is y squared. Right, then last thing we said what we need to do, because now my, if you look at here, a squared minus b squared, my a will be x squared, b will be 5y. Then I'm going to say x plus 5y, this plus this, then x minus 5y, because we said a plus b and a minus b. A is x and b is 5y in this case. So x plus 5y times x minus 5y. Right, so everything is happening in the bracket of 3. Okay. All right, so some of these questions, yeah, they are in the, we can solve them with the difference of 2 squared. I'm just quickly gonna go through these examples here. See, p squared minus 64, the first one. I do know that 64 is what? 8 to the power of 2, right? 64 is square of number 8. Then p squared minus, if I write this 64 in the form of an exponent, it will be p squared minus 8 to the power of 2, right? 8 squared. So this is 1 square, this is 1 square. So difference of these two squares. Then if I call this here as a, and this second, the term I'll call it b. A plus b times a minus b. A p plus 8 times p minus 8. Right, so that is going to be the answer. The next one is here, 121 minus y squared. Now y squared, it is in the form of exponent, but if you look at 121, it is a whole number. But I do know that 121 is the square of number 11. So it's 11 squared. Now I'm going to write like this, 11 squared minus y squared. So then I'm going to say 11 plus y times 11 minus y. The next one, x squared minus 36y squared, right? Here, the only thing that is not in the form of an exponent is 36. So I do know that 30, the 36, guys, the number 36 is, right, equals to 6 to the power of 2. Right. So then 36, see if that is, right, how it's written in, when we write it in exponent, the term here is 36y squared. Then I do know that this 36y squared is basically, the 36 is 6 to the power of 2. If I say this, I write it like this, this 2 is power of 6, power of y. 6 to the power of 2, 6 times 6 will be 36. Y to the power of 2 will be y squared. Okay, that's how we get it. Then the first term will be x squared. The second term will be, as you can see, right, 6y squared. Then my factors, when I factorize it, it's going to be x plus 6y times x minus 6y. Okay. This looks a bit different than all the previous questions we have done, but we can do it. It's not a problem at all. X squared, x minus 2 squared, right? We just leave it as is because this is going to be my, I'm going to call it A, and then B will be this. Then I'm going to apply the rule A squared minus B squared. Since B is 49, then 49 is what? 7 to the power of 2. So when I do that, guys, so this is going to be x minus 2, right? First here, x minus 2 to the power of 2, right? Minus 7 to the power of 2. That there are two squares here. So I'm going to say this is going to be my A, this is going to be my B. Then x squared, x minus 2, sorry, x minus 2 plus 7 times x minus 2 minus 7. So why I'm saying here it's plus 7 and minus 7, because if I write everything here in the bracket, right? So it's obviously going to be, if you write this here in the bracket, x, that's everything here. If you write in one bracket, power of 2, power of 2, you can write in the one bracket. So it's going, basically, it's going to be this, right? X minus 2, as you can see, we said this is, okay, to the power of 2, right? Minus 7 to the power of 2. Right. So this thing here itself is, right, x minus 2 to the power of 2, x minus 2 plus 7 and minus 7. Because I'm going to say, because this is the difference of a squared plus b squared equals to a plus b times a minus b. Then a plus b will be, right, the second of 7 squared x. So this is basically x minus 2 minus 7 times x minus 2 plus 7. So then when we work it out, right, we work it out, then it's x minus 2 minus 7 will be x minus 2 minus 7 will be minus 9 times x minus 2 plus 7 will be plus 5. It's going to be 5. So the final thing will be x plus 5 times x, you can see here also, x plus 5 times x minus 9, or you can say, obviously, sorry, this is 9. Okay, let me just rewrite it. Okay. This is, okay, minus 9, because negative 2, negative 7 is negative 9. So x minus 9 times x plus 5, y plus 5, because negative 2 plus 7 is positive 5. Here, negative 2, negative 7 is negative 9. So my factors are x minus 9 times x plus 5. Okay, you may be thinking now, here it says x plus 5 times x minus 9. Remember, we said there is no difference between saying x plus 5 times x minus 9 and x minus 9 times x plus 5. It's the same thing. It's just a matter of which one you're writing first. All right. Okay, so yeah, it's just same as what we have done previously. As you see now, 4x squared minus 16, 4x squared, right, equals to 2x squared, because 4x squared, 2 to the power of 2, yeah, this power of 2 is power of 2 and x, 2 times 2 will be 4, 2 to the, x to the power of 2 will be x squared. So this 4x squared, then 16 is perfect square. 16 is square of number 4, right? So now when we're solving it, we're going to say 2x plus 4, since here we got 2x plus 4 times 2x minus 4. Right, you take one positive, one negative. Okay. All right, this is also the same thing repeated here. Here it's just asking if this is a perfect square or not. Say, for example, if I do this one here, I'm going to just prove only one of them why it is a perfect square. Because if you say, right, x squared minus 64, right? When we set 64 now here, it's a whole number. I need to write it in the form of an exponent so that I get difference of two squares. So x squared, this equals to x squared minus 64 is square of number 8. So it's basically 8 to the power of 2. As you can see now, I have two squares here, x squared and 8 squared. Then the rule for this was, as you can see here, a squared minus b squared equals to a plus b times a minus b. A is x, b is 8. So I'm going to say this equals 2, right, x plus 8 times x minus 8. Right, so this is going to be the answer. This is why it is a definition of two squares. All right. Okay, so as you can see here, there's another question of that. So the main thing is this. When we see a squared minus b squared, right, that equals to a plus b times a minus b. The reason we call it difference of two squares is you can see this one square, this is another square. So there is a minus sign in between. This is the difference of these two squares. Right, so if we have to do this one, okay, for as last example, x squared minus 36, I need to write it in the form of an exponent, which is going to be 6 to the power of 2, x squared minus 6 squared. Then I'm going to say x plus 6 times x minus 6. Okay. Right, okay, these are, as you can see here, which are the ones are difference of two squares is this one and this one, because other example, obviously we aren't able to solve them as under difference of two squares because they aren't. All right. Okay. I think this is it's about difference of two squares. Okay, I will now move on to next topic, which is going to be factorization by grouping.